Have you caught the recent excitement about NASA's New Horizons mission? I haven't been able to stop thinking about it for a couple of weeks now. Why is this amazing to me, and what is the significance to it? Bear with me, because there's some background to it. This vessel and the space scientists at NASA were able to get to and send back pictures of the most distant body ever visited by humankind, called 2014 MU69, but after a public invitation to submit name suggestions called Ultima Thule, meaning the extreme limit of explored territory. But it's not just that this is the most distant object ever visited. It's the meaning of objects like this that really matters. And that takes telling a story. Well, two stories. Let me start by telling a little bit of the personal story, and then I'll tell a minute piece of the scientific story. Once upon a time, there was a 4-year-old kid who found out he lived on a planet. This blew his mind. What's a planet? What's beyond the planet? What was the physical situation he'd been born into? It turned out there was a vast universe of which the Earth was only a minuscule part. But on a more local level, the planet Earth was part of a solar system, which was held together by the gravity of a star called the Sun. Wow. And then the kid filled in the picture of what was then known, which actually turns out to be very incomplete based on what we know now. Here was that picture. There was a central sun and 9 planets, and between Mars and Jupiter there was an asteroid belt, and beyond the solar system there were an unimaginably large number of other stars and solar systems that made up our galaxy, the Milky Way galaxy, and beyond that, countless other galaxies that were racing away from each other in a cosmic expansion that started with the Big Bang. Well, this was amazing, and the kid dreamed that one day, when he grew up, we'd have advanced spacecraft and he'd spend his life exploring the universe. You may have your own version of that story too. But it turns out that in fact, the actual picture of the solar system is somewhat different from the picture that I learned as a child. Okay, Pluto has been demoted from a planet to a dwarf planet, which means it's massive enough for gravity to have compressed it into a roughly symmetrical shape, and it orbits a star, the Sun, but it hasn't cleared the neighborhood of other material. True planets have cleared their orbital paths of large objects and debris and smaller objects left over from the formation of the solar system called planetesimals. But beyond the reclassification of Pluto, some of the largest structures in the solar system were unknown when I was a kid. Certainly one of the largest is the heliosphere, a vast region that surrounds the solar system in the solar wind, consisting of a constant flow of charged particles from the Sun. This extends out to 80 to 100 astronomical units, where 1 astronomical unit is the distance from Earth to the Sun. Another very large structure is the Oort cloud, a cloud of mostly icy planetesimals surrounding the Sun at distances of 2,000 to 200,000 astronomical units, out into interstellar space and lying beyond the heliosphere. This region is thought to be the source of long-period comets, comets whose cyclical period is greater than 200 years. But the large structure we're concerned with today was also not discovered until the 1990s. And the story of its discovery is a fascinating one, but that's a story too much for today. This structure is the Kuiper Belt, a vast donut-shaped ring of material that exists about 30 to 50 astronomical units from the Sun. The planet Neptune orbits the Sun at 30 astronomical units, so the Kuiper Belt is that material that extends beyond the orbit of the planet Neptune to about 50 astronomical units, which is why the objects in the Kuiper Belt, also called KBOs, Kuiper Belt objects, are sometimes called trans-Neptunian objects as well. Though it may consist of many, even thousands of dwarf planets, of which Pluto is the most famous, it mostly consists of smaller bodies called planetesimals. In some ways, the Kuiper Belt is similar to the asteroid belt in that it's a vast ring of orbiting material that hasn't coalesced into a planet. But there are important differences. Asteroid belt objects are mostly composed of rock and metals, whereas Kuiper Belt objects consist largely of volatiles, ices, on their surfaces, like frozen water, ammonia, and methane, and have interiors of unknown amounts of rock and ices. This starts to get at what is so special about KBOs. Asteroid belt objects are not remnants of the early solar system. These objects have undergone considerable evolution since their formation, including melting from the heat of impacts, weathering from radiation, and bombardment by small debris and meteoroids. Kuiper Belt objects, on the other hand, live in a far different environment, far from these effects, and thus have undergone minimal alteration since the formation of the solar system. So these do appear to be remnants of the early solar system. Today's most prominent model of planetary formation is an accretion model, and I'm only going to touch on it here, although I may make a future video about it. Here's a super abridged description. Much of the material in a newly forming solar system is sucked in by gravity into the forming protostar. The remainder forms a massive disk called an accretion disk around the forming star, composed mostly of gases and cosmic dust. Cosmic dust particles begin to adhere to each other within the disk, growing the particles over a long period of time into boulder-sized objects called planetesimals. The more massive planetesimals acquire more gravity, causing them to pull or accrete smaller bodies into themselves. It is the progressive accreting of more and more material into the planetesimals over millions of years that ultimately results in the formation of large bodies called planets. It's possible that the material in the asteroid belt might have coalesced into a planet if that region wasn't constantly being disrupted by the massive gravity of Jupiter. Similarly, the Kuiper Belt material might have coalesced into a planet if Neptune hadn't been there. Neptune's gravity stirred up this region enough so that these small icy bodies were not able to coalesce into a planet. Thus, these KBO, dwarf planets, and small planetesimals have orbited beyond the orbit of Neptune since the formation of the solar system some 4.6 billion years ago. These are mostly the objects that formed furthest away from the forming sun within the protoplanetary disk, and have stayed there ever since or been pushed further out by Neptune. In this way, small planetesimals like Ultima Thule are the preserved building blocks of the planets in the early solar system. They're the raw materials that went into the formation of our planet. Finally, after more than 4 billion years, we look again at the elemental pieces that formed our planet. You could call this an astronomical fossil, or you could call it the solar system's oldest time capsule, or you could just call it fascinating. In fact, it's astonishing. New Horizons had already visited the dwarf planet Pluto and sent back fantastic and unexpected and dramatic pictures of the surface of Pluto, including an 11,000-foot mountain and water in the form of brilliant ice. I'll do a video on that in the future, and one on star formation. After all, I have some questions about just how massive clouds of interstellar gases collapse to form stars and protoplanetary disks. But for now, look again at 2014 MU69, Ultima Thule. It turns out to be a contact binary planetesimal. In other words, two smaller planetesimals have come together and are now joined. The mutual gravity of Ultima Thule's two lobes appeared to have pulled the two lobes together. That is what I've been unable to shake for a few weeks now. How remarkable that our first glimpse of these primordial objects, the materials that formed our planet, so sharply display the accretion of small objects to form larger ones. Frozen in time, two smaller planetesimals have come together in a visual depiction of the process by which our planet grew in countless similar events, from tiny pieces of rock and ice, ultimately to become this living, blue, beautiful planet that we are so privileged to walk upon. Be sure to subscribe. You can follow my Instagram, and thanks a lot for watching.